So let's start with this problem. The question is valid binary search tree. Description given as given the root of the binary tree, determine if it is a valid binary search tree. Okay, the definition of BST is given here. So basically we have to prove that whether the tree which is given is BST or not. So let's see how to prove that. So let's open whiteboard. Yep. So let's see. First of all, what is BST? So for a quick recap, BST is nothing but a binary tree which is having its left node which is smaller to its root node and right node which is greater to its root node. Okay, so how to see? Suppose this is a 3. What is a valid binary tree is if we put 1 here, okay, and if we put 5 here, so this is a valid binary tree. Okay, suppose this is our root node. Suppose we have to put a node which is greater, it always comes to the right side of the tree. Okay, similarly we can see that this is a binary tree. Suppose let's see 1 2 5. Okay, so is it a valid binary tree? No, it is not a valid binary tree because we can see here our root node should be greater than which is left side of our tree. Basically 1 is smaller than 2 when we are traversing left, so we can't consider it a binary tree, binary search tree. Okay, so for that binaries we can as we can see, we can put 2 on the right hand side, so now it will become a binary tree. Okay, so this is a binary tree. Now how to find a binary tree, whether it is a binary tree or not? So first of all we talk about traversal technique. Okay, traversal. So in traversal technique there is a one technique called in order, in order traversal. Okay, so in order we are basically traverse first to the left side of the tree, then root, then right side of the tree. So as we are traversing, the left side of the root node is always smaller while the right side of the tree is always greater. Okay, so it's basically look like as left is always smaller than root and it is always the root is always smaller than right. Okay, so basically this is a look like. So this is how we can find whether the tree given is a binary tree or not. So let's uh, basically dry run it. Suppose we have a binary tree named as let me draw a binary tree first. So this is our binary tree. So let's find out whether this is a valid BST or not. Okay, so first of all we have to find a pre-order. Okay, so how to find pre-order? In my previous videos I talk about three different techniques: pre-order, post-order, pre-order, post-order, and in order. You can find there how to find how to traverse a tree using these three techniques. So in pre-order, first we cover left side, then root, then right side. Okay, so basically in my previous video I used this technique to find uh, how to find, basically this is in order. Okay, so let's start. 2 3 4 5 6 7, 3 4 5 6 7. So this is our in order. So let's check. Our left side is always smaller than our root. Suppose we take two pointer I and I plus 1. Every time we traverse, we check whether our left side means ith index always smaller than the I plus 1 index. Okay, so we see all the elements, all the numbers satisfy this condition, so it is a valid BST. It is a valid BST. Simple. Okay, if it does not, we put it is not valid BST. Suppose, let me do some changes so we can find it again whether it is a BST or not. So let's put a wrong node here. Let's mark it with red node. Okay. So suppose every child uh, on the left side will be smaller to its root node. So let's put a greater. Let's suppose we put 8. Okay. Let's find out whether it is valid BST or not. So let's find first of all in order. So for in order, we traverse again 2 3 4, 2 3 4, 5 8 6, 5 8 6, and then 7. Okay, so this is our in order. Let's find out whether our I plus 1 index is greater than ith index. So in this condition true, in this condition true, this is also true, this is also true. But here we can see, let me draw it with thread pen. Here we can see this is our I index, this is our ith plus 1 index. So the true condition which is said that I should be smaller than I plus 1, which is a for true BST. But here we can see that it is not following our base condition, so it is not a valid BST. Okay, so let's try to code it. So how to code it? First of all, we have to make a vector to store our answer. So first of all, we make a vector. Suppose let's make a vector. uh, let's name is in order. In order. Okay, so after making in order, we perform in order traversal. In order traversal. Okay, so in order traversal, we pass our root node along with our in order in order vector. Okay, so let's write a private function. In private function, we declare our actually this is a void, does not return anything. We simply pass our in order by address, so it doesn't require any return function. So in order traverse, here we capture our root node. Root node, this is our root along with vector in order. Okay, simple. Now how to traverse in order? First of all, we put base condition over here that our root node, not if it is equal to null, then we break our recursion. Okay, this is our base condition. Base condition. Okay, simple. Let me, can we increase font? Yeah. So yeah, now we have to find our in order traversal. For in order traversal, we first go to our right left subtree, traverse root left. Let me correct it. Root left along with in order vector. Okay, after that we are traversing left side. We fill our root basically in order vector, in order dot push back with the value of root. Okay, simple. Let me, and after that we traverse right side, traverse root right, passing our in order array. Simple. Okay. Now, after making our in order vector, in order array, basically what we both are the same things for this question. So now what we have to done? First of all, we have to traverse array int I is equal to 0, I less than equal to, not less than, it is, what is in order dot size, in order dot size -1. I will explain you why I put -1 here. Okay, so bam. Okay, so now if our vector which is in order ith is not smaller or equal, yep, equal than in order I plus 1, here we can see that we are basically traversing. Let me open my whiteboard again. So white, yep. So if we have a array, so we have to traverse till here ith position. The ith plus 1 position is calculated at the ith, so we are taking size -1. Okay, so it does not over basically give sanitizer error. Okay, basically you are accessing a memory which is not declared by you. Okay, simple. So for that, if we found this condition, we simply return that our this is not our valid BST, else return our true. Yeah, you simple. Okay, let's try to run this. Yep, it's true. Let me try test cases also. Yep, let's try to submit it. Yep, it's submitted. Okay, accepted here. So thank you. Have a nice day.